So, ephemeral environments. As the name suggests, what do you say? What exactly is ephemeral environment? Anyone has implemented any sort of concept within their organization? Yes. So, what are ephemeral environments? Yeah. So have you used that in Kubernetes ecosystem or outside Kubernetes ecosystem? In Kubernetes. So what exactly do you do? Like you create the namespace, deploy your applications, and then?
Like let's say you have certain set of applications, and you want to deploy it. Like you want to you say you want to deploy the features, and you don't want to deploy it in a manually. So you'll just bring your documents and put it on it and with the backend.
Okay.
And you can define the DTN and everything. And if I drop it running, it's going to get the DTN. Okay.
Okay. So what are the benefits of using ephemeral environments, if I may ask? Why did you decide to use ephemeral environments and not a static environment?
Mainly on feature development. One developer is doing a certain thing, and another developer wants that feature, wants to do develop feature analytics in the same application. They do not want to deploy it on the running tester level. So they can work parallelly, they can test, and they can just let's say they created one code for there, and let's say they have to phone another. They can create a code for that app as well, they can connect it, and it makes faster for them.
Right, and cost efficient as well, because you do not have to spin up the entire environment all over again every time you need a new feature to be deployed, right? So yes, one of the reasons for ephemeral environments is also cost, because I don't know your use cases, but my company incurs 5x in non-production than in production, because we are not SaaS solution. So our non-production cost is almost 5x than our production cost. So we need, whenever we have to optimize, we do the optimizations in non-production environments first, right? So that is us. Right. So I've been working as a solutions architect with Devtron right from its inception, 5 years now, since the company has incepted. And I've been in the industry for almost 12 years. These are my credentials. You can follow me on Twitter, GitHub, LinkedIn, connect me. I'll be using a few, so I won't be focusing much on the slides because I have a demonstration as well after that. And so I've compiled a short slide for this particular event. So that will comprise of understanding what exactly is the ephemeral environment. I think most of you already have an idea, but I'll take a different approach in how exactly is ephemeral environment different in Kubernetes rather than in other ecosystems as well. The conventional approach of your ephemeral environments and some common misconceptions around ephemeral environments will be discussed, and then some out-of-the-box strategies for cost efficiency. So I would not say that it will be directly impacting your cost. Some of those points will be impacting your cost directly, but the other things will be indirect cost optimization for your Kubernetes as well. And then some practical solutions that I talked about, we'll discuss. So 2 of them. Okay, so like he said, ephemeral environments are short-lived deployments that cater to a developer's use case, wherein a developer is testing out a particular feature. He wants a few set of applications to be spun up from maybe his feature branch. All of those will be spun up. And then once he's done his testing or maybe run some test suites and all, and then he'll just wrap up by destroying that particular environment. So destroying that environment concludes the ephemeral environment's use case, right? The conventional approach is generally what? We build our container image, we spin up the infra, virtual VMs or DBs that are required, and then we also use shared DBs in some cases. Then we set up the configurations, your config maps, your environment variables, your secrets if your application is interacting with external databases or services. We deploy the application into that environment, and then once we have tested everything is working fine, I'm satisfied, I'll just go ahead and nuke it, right? I'll destroy the entire environment. Maybe if I have spin up using Terraform, I'll just do a destroy. Right, so that is how a conventional approach works in case of non-Kubernetes ecosystem. But with Kubernetes ecosystem, what happens is, you're not spinning the infrastructure because Kubernetes handles it. It automatically scales to cater to your needs, right? So I have removed one step. So my steps start from building my container images, and then setting up the configuration for those in my maybe a namespace. So namespace, as you know, in Kubernetes lingo is like a logical separation for having multiple environments that that may host multiple environments, or that may host that may separate your application workload from your infra components and all. So you can have a logical separation in terms of namespaces in Kubernetes. So namespaces can also be utilized as environments as well. So in my one cluster, I can have dev1, dev2, dev3, dev4, and dev infinite environments as well, right? So having a namespace in Kubernetes does not incur you any sort of cost, right? So if technically I'm just creating a namespace and then deploying my applications in it and then leaving that namespace as it is, it's not incurring me any cost if I'm scaling down my workloads or deleting my workloads at the end, right? So I do not have to set up configurations again and again. One thing, I only have to do a kubectl patch or even patch the configurations that I need to change for my specific use case, and the rest of the configurations are already there in that particular namespace if I'm reusing that, right? And then I'm also not incurring costs, so that is another thing. And then once I'm done with my stuff, what I can do is I can just scale down all the workloads within that particular namespace. I will discuss two approaches to do that in the later part of the slide. And then these environments are reusable then, right? So you do not have to create the environment and then delete it and then recreate it every time in case of Kubernetes, because having a namespace created in Kubernetes does not incur you any sort of cost. So, but it also saves you from the hassle of configuring your config maps, your configurations, other configurations, your service accounts. So all those hassles are not required every time, right? So that is how a Kubernetes approach on ephemeral environments work. I'm sorry. So common misconceptions around ephemeral environments is that you have to nuke every time, right? But in case of Kubernetes, like you know that if I'm clearing all the workloads or I'm scaling down all my workloads in a particular namespace, I'm not incurring any cost. So even if I delete the namespace, it's not going to save me any cost, right? But next time when I have to create all these configurations, if I have to create a new ephemeral environment, I'll have to redo all these configurations. Your service accounts will need to be redone. All the secrets will be needed to be redone. So it's sort of having a disadvantage for me in case of Kubernetes, right? So it's a very common misconception which multiple companies I have encountered. So they say that, okay, I need to create a namespace, a dynamic namespace, and then I have to delete it. So that is ephemeral environment for me. But what we follow at Devtron is we have like around 25 to 30 environments which are always up. So these namespaces are always up. The base configurations are always applied. The service accounts are always there. The developer only needs to deploy their images in that, right? So, and those environments are scaled down when the environment is not getting any sort of request. So I'll tell you how we have achieved that in the next slide. I'm sorry. Okay, so I'll be first discussing on some of the strategies for cost efficiency in Kubernetes, and then I'll be showing you the demo of how exactly we have achieved it in our non-production environment. So first of all, leverage spot and preemtable VMs in case of your non-production environment. Our non-production environments run on 100% spot nodes. So we select low disruption spot nodes. We have mechanisms in place which sends the signals from the cloud provider for a rebalance, and then gracefully rebalance the nodes in case of a disruption is expected. And not it is interrupted. So we generally get a 2 minutes notice in case of a spot interruption is about to happen. But AWS and other cloud providers, they also send you a expected capacity balance notification as well. So let's say that they send you a signal that this particular node can be evicted, right? If it gives you that signal, you can start your node rotation gracefully, right? Because 2 minutes is not good enough time to most of your applications to get into a healthy state, and the new VM may take 30 seconds to come up, and then you can start draining the workload. It may take that time, right? It may take more than 2 minutes as well. So it's better to rotate your instances as soon as you get this notification that this capacity rebalance is expected, right? So that's how we are managing our preemtable VMs and on AWS and Azure. Second thing to keep a tab on is data cost. So recently there was an instance in our company. So we had this single AZ EKS cluster, and we started getting a lot of data cost from that particular cluster. Right. So I was analyzing this particular data cost, which was like very high for that cluster, for a EKS cluster. So what I figured out was we had all our VMs in AZ-A, and our NAT gateway was in AZ-C. So we were continuously incurring this intra-AZ cost, and this is something that might look very minute in some cases, but it was very high in our case because our infrastructure was relatively low, and we were continuously, so we do builds and deployments, right? So the builds were fetching all the cache from S3 bucket and other locations, and then they were also pushing these images to different container registries, including QA and ACR, right? So we maintain our images at multiple registries, right? So all that data transfer was happening, and generally what happens is the NAT gateway cost is not that high as compared to the inter-AZ cost. So we instantly checked on this and rectified this. We brought the NAT gateway to the right availability zone, and that reduced almost instantly. This cost was zero for us. So you have to keep a tab on the data cost, because we talk about the cost optimization. We straight away talk about VMs, right? Because that is a large chunk of your entire infrastructure. But do not ignore this data cost as well, because that can also tend to be very high sometimes. Consider self-managed solutions, which will be like, I do not need a RDS for my non-production Postgres, right? So have it in the cluster itself rather than getting a RDS instance from Azure. AWS. Similarly, you can have a MongoDB in the cluster itself rather than having a managed solution of Mongo, right? So you can consider these changes within your organization to bring down the cost. Consider cheaper deployment strategy. Efficient build and deployment systems. Okay, so this one is often overlooked, which is like considering the efficient build and deployment systems. Because if I'm asking my developer to wait for 30-40 minutes to get a build completed, it's a waste of their time, right? Out of 8 hours, if he's waiting 30 minutes to get the build completed, it's a waste of their time. And if you across an organization, if 100 developers are wasting 30 minutes of their time, it's a waste of resources and it's a waste of cost for the company as well, right? So you should be working towards building highly efficient build and deployment system in that case. Because if I talk about a conventional developer, they do at least 2 times they build a image, right? So I'm taking an average, right? Generally what happens is the builds are automatic in non-production environment, right? So if a developer is committing some code, it automatically starts building. The VMs are up, your Jenkins workers or any build workers are up for that duration, and it is also a cost to your organization. So always optimize your build and deployment systems as well. Consider cheaper deployment strategies. I've seen companies having blue-green deployments in non-production, and I don't know why, right? I've seen companies having blue-green deployments even in production and not using the blue-green deployment strategies efficiently. If you're not using any functionality of your application, you should consider lowering down the cost of the deployment strategy. Why not go for a rolling deployment instead, right? So I'll tell you scenarios. Let's say my application has 40 pods, right? If I do a blue-green deployment, it will spin up 40 more pods, total 80 pods, and then it will scale down those 40 pods, the older replicas, right? What happens is, for these 40 pods, I may need 5 more VMs to be added to the cluster, right? I added these 5 VMs, considering, okay, I'll also vacate the 40 pods, and that will also free up my resources, but that generally does not happen. So you saw that graph that CastAI guy showed you. So that is probably because of this deployment strategy. Because the 40 pods which were vacated after the blue-green deployment happened, so those VMs are also occupied by other application pods as well, and they can't get evicted. If they get evicted, either other applications will face disruption, or that will hamper your SLAs in some fashion, right? So always consider, in case of a rolling deployment, if you do, in this case, you might not need any VM at all if you're rotating your pod one by one, right? So always consider deployment strategy when you are doing deployments either in non-production environment or in production environment, right? The way it would be, blue-green deployment has most cost associated with it, and then rolling, and then recreate, right? So recreate is least. So it just removes all your old pods and then creates a new pod. So we recently, so one of our enterprise customer had an entire cluster dedicated to all the consumers. So those pods were all consumers. So they were doing a rolling deployment strategy. We suggested them to go for recreate, because anyways you're not using the rolling strategy efficiently, because those pods are not getting access from anywhere. They are just consuming from a Kafka topic, right? So in their case, it wasn't any sense to do the rolling deployment update, right? So we suggested them to go for a recreate strategy instead, and they saved a lot of costs because of that. Right, so just changing the deployment strategies in your non-production environments or in your production environment can also save you a lot of cost in that sense. Right size the workloads. So workloads can be your pods, can also be your VMs as well. So when I talk about right sizing your workloads, always see how much application is utilizing based on previous information gathered in your Prometheus, getting it from Grafana. You can right size your pods. That responsibility can also be offloaded to the developers as well. Like Vijay told in his presentation that you need to tell them that, okay, you are incurring this much cost on our infrastructure, right? So if the moment you tell them that you are incurring this much cost in our infrastructure and you need to optimize it, you give that liability to the developers. They'll start seeing their regular usage pattern, and they'll right size their pods accordingly, resources accordingly. And then workloads, so VM right sizing is also required. So I've seen multiple companies, they use R series instances, and then they are not even using 20% of the memory allocated to those instances. R series is like 25%, almost 20% costlier than M series, and they're almost 35 or to 40% costlier than C series. Just bringing them from R series to C series will almost save them 40% of their cost, which can be huge in case of huge clusters, right? So that was about right sizing. In case of applications where you are sharing the cluster with multiple teams, and each teams have different requirements. Some may be CPU intensive, some may be memory intensive. Always use different type of node groups for that purpose. So give it taint, give the nodes taint, and then give your application toleration for to those taints, and schedule those particular memory intensive applications to those memory intensive VMs, right? So in that case, you can distribute your applications very efficiently. So that was covered in the use correct VM family and size. I've also seen multiple companies using Kubernetes clusters. They have like around 150 VMs in that in their Kubernetes cluster. And then when I check the size of the VMs, it's generally large VMs or X large VMs. I tell them, okay, why don't you use 2x large VMs or 4x large VMs? Because having a larger VM gives you two flexibilities. One is your application can use the burst, right? And then second is that you will have lesser number of daemon sets. So let's say I have a fluent bit daemon set that keeps shipping the logs from my VMs to my central logging system. And I have 150 instances, right? I'll have 150 pods, which will be there in my cluster, all one on each VM, all shipping logs to my central logging. But if I reduce this, if I increase the VM size and reduce the numbers to, let's say, 40 VMs of, let's say, 8 core each, it will dramatically decrease the number of pods that I have in my Kubernetes cluster. And this is just example of one daemon set. Generally, companies have at least 5 to 6 daemon sets within their Kubernetes cluster for various purposes, right? So using the size, right size is also important. While your application will have enough space to breathe in a larger VM rather than in a smaller VM, because let's say that you have allocated one request CPU and limit is 2, right? If your VM size is 2 core or 4 core, if you have multiple applications put on those VMs, it will not be able to burst till 2 cores most of the time, right? But if you have these applications in a 8-core machine or a 16-core machine, it will definitely have enough CPU cores in case of burst, right? So always use a large size VM rather than large number of VMs. Sorry. Right. Some practical solutions that I wanted to discuss was, first is scale down when there's no traffic. So scaling down your entire environment when there's no traffic in your non-production environment is not harming anyone, right? If a developers come in, they hit the dashboard, your applications will start scaling up and they'll soon get the dashboard. Maybe a couple of requests may fail sometimes, but eventually they'll have the entire environment set up within a couple of minutes, right? This is very convenient, but it required some effort from your side, so that you have to implement that within your organization. So it depends on the kind of applications that you have. All of them may not be HTTP based. Some may be consumers. Some may use other request methods. So it will depend on your organization how exactly you want to implement this. I'll show you how we have implemented this. And second is time-based scaling. So previously what we were doing was we had this time-based scaling setup for our non-production infrastructure. So it will scale down our entire non-production cluster on Friday night, and then it will scale up back on Monday morning. Right. So almost 25% cost saving straight up. Right. So I'll show you how you can do this. So for HTTP request-based scaling, we have used Keda HTTP add-on for that purpose. So what HTTP add-on does is it has a service called interceptor. Whenever a request is forwarded to this interceptor, it holds that request. It sends signal to Keda to scale up the underlying objects. Once the objects are scaled up and are healthy, it replaces that particular request back to that particular service. So it holds on to your request for a fixed duration, whatever you have configured. So let's say I've configured my to be 100 seconds. So if in 100 seconds my application is not up, it will fail that request. But the next request that gets it will get that particular application up and healthy, right? So I can quickly show you a demo. Why is it not showing the entire screen? इधर वाली स्क्रीन कैसे आएगी? Okay. Yeah. So I'll just go to resource browser. I have this one set up on shared AKS cluster. Pods. Okay. Now I need that one. Okay, so this is 25th environment of our non-production. This is right now scaled down. So these are some supporting services which are shared. So that is why these are up. Otherwise, the entire cluster is scaled down, right? I'll just hit this. So this is the URL for this particular cluster. So I'm just gonna make a request on this. Right, and then I'm coming back here. I'll do a refresh. Okay, I can see that one of the services have come up. I can see Argo CD deck server is running. And then a couple of more pods are brought up. And then if I go here, I can see the dashboard. So the supporting services are still coming up in the background because once one service is up, it's sending a request to other supporting services and they are coming up in the background. But my dashboard is up. So now what I can do is I can log in and start doing my testing and all. And once I leave this particular application or I just close the tab or I'm not doing anything, it will automatically scale down within 90 minutes, right? So although I have 25 to 30 environments set up, they are always running. As soon as they are idle, they scale down, right? So they scale down, all the pods scale down, and then my cluster autoscaler kicks in and it removes or drains the empty nodes, right? So thus bringing down the cost of my infrastructure. How I have done it? Just let me refresh this once more. You can see that almost 8 pods are up. So this will like bring up almost 13 microservices. But let's not wait for that to happen. Let's quickly jump on how did we do this. Coming back to this one. Can you see it? Okay. So I'll have to explain it from a little closer. So what I've done over here is, so this is a HTTP scaled object. This is a HTTP scaled object that you will need. Zoom doesn't happen in full screen, I guess. I can share the slides later on. So this is the HTTP scaled object from Keda, HTTP add-on. What happens is you'll need this particular object for each of your applications. So this will be configured for each of your microservice. And what it does is you'll need to specify all the hosts from wherever this can get this request. So I have configured one as my ingress host, and others are like my internal services. So other services can call this service from all these service names, right? So I've configured this. So now any request that is coming for this particular host will be sent to this particular service. So this service is directly patching to my pods. Right, this is the conventional Kubernetes service that you would use, and these are patching to my pod. So all the requests that are being forwarded to these hosts, interceptor will send all those requests, forward all those requests to this particular service that I have specified over here. I've also specified what particular object I want to scale up when I get a request on this particular service. I've specified it's a kind rollout in my case, and the name of the particular rollout object that I want to scale up, right? So once you set up all applications with this HTTP scaled object, you can use it effectively to like scale down your application or scale up your applications on demand, right? So this is one implementation. By the way, this is not production ready yet, but we have implemented it with multiple of our clients. One of our clients, I would not name, but they have almost 30 environments, 200 applications per environment, and they use this. It's working flawlessly with their non-production use cases. Their developers have to wait almost for about a minute for their first service to come up, and then it takes almost 5 to 6 minutes to scale up the entire 200 applications stack. Right. Another thing is the Winter Soldier. So this one is created by us. It can be used to scale down or to remove the objects from within your cluster, right? So you can give it a time duration. So I can give like Friday I want to scale up. Friday I want to scale down my applications, all the applications. Apart from a few applications which are there in Cube system, let's say, I want to scale down all these applications to 0. So this can be achieved using this Winter Soldier functionality. This is available as a Kubernetes deployment. You can just have it inside your cluster, and then you can use the CRD to apply it at your Kubernetes cluster level. So I'll just quickly explain this as well. So this one is taking primarily three things. One is action that it has to take, which is right now sleep, which will scale down my workloads to 0 replicas. The other action is delete as well. So that will just quickly delete your application, whatever you specify over here, right? This is it. Exclusions, whatever things you need to exclude from the purview of this particular configuration. So I want to exclude all the stateful sets because of obvious reasons. I do not want to mess up with my databases and all. And then I want to exclude everything which is there in kube system, Devtron, CD, kube nodes, lease, kube public, right? Apart from these namespaces, all are my non-production environments, right? So I can exclude all these things. And then in the scope, I have given all the namespaces. Exclusions are these namespaces, right? So these configurations that they can run from, I've configured it to run from Friday till Sunday, when to kick in, so you can specify the time range over here. And this will scale down all the workloads on my Friday night, and then also bring up the entire stack on my Monday. And this happens for all the namespaces. So irrespective whether a new namespace is getting created, that will also get scaled down as well, right? That is another powerful tool that you can use within your non-production environment to scale down your application. By the way, this can also scale down to a level as well. So let's say that we implemented this for a logistics company. So the logistics company had a backend API for the mobile application that the delivery guys use. So as soon as a courier is delivered to you, they mark it delivered from there. They also take your signatures on that same application. So this was implemented in their use case because their workloads were, so the deliveries happen only during daytime, right? So we used to scale up this application during day at 7 a.m. And then we used to have a constant number of replicas of that particular application always up throughout the day. And then at the end, at the night, we used to scale down that particular application to like a couple of replicas as well, right? Request-based auto-scaling and CPU utilization or memory utilization based auto-scaling was not very applicable in their case because it was a very heavy application and it will require a lot of startup time for this application to kick in. Gradually, they changed the entire stack of that application. They made it in, read it in Golang, and then they made all these modifications to make it, to optimize those things, right? But we implemented this in production. So that is about, so this is the architecture of KDA HTTP add-on. I've already explained to you how it happens. You get a request from client side using a load balancer and ingress. It lands onto your service. Then the service sends this request to the interceptor, the KDA interceptor. This in turn kicks in the HTTP operator to scale up the scaled object, whatever you have defined. This can be from deployment, this can be from rollout, or anything that supports scaled object. Once this pod comes up, it replays it to the original service of the application, and then it goes to the original deployment, right? So this is how the KDA HTTP add-on handles the scale-up process. Any questions? I think that's the end of the slide.
Thank you so much, Prakarsh. Huge round of applause for him.
Hi. So I have one question. So we were discussing about the deployment strategy recreate. Okay. So we discussed that there can be a worker-based application which listens from the party topics and messages and then perform the operation. So what if I'll say that someone did the deployment and it didn't come up? What then in that case, recreate will delete those ports and newer ports won't come. So in that case, how it will be? I don't think that will be the most beneficial use case of recreate because
so your new application pods are not getting
up. Yeah.
There can be numerous
yes.
right? But if a deployment has taken, if whatever configurations you have provided to your deployment object or to your rollout object, it gets validated against the API specs, right? Mm-hmm. If everything is fine over there, this deployment will happen, right? It may be a possibility that the new pod that has come up, they can fail as well, right? But in case of consumers, you can sustain a certain amount of lag in that case, and you will get that notification if you have, or you can kick in the rollback as soon as possible. When you see this pod going into crash, you can kick in the rollback, right? But in case of your consumers, you can sustain a certain number of lags within your Kafka topic or anywhere, right?
One more thing. This vector soldier, there are multiple tools to like make the replicas to zero and all this. But major disadvantage is they just scale back. Okay? And in an organization, generally 90% of that use some help or some package, right? So whatever it scale down, if someone wants to do a deployment, most of the cases it won't be the case. No one wants to do the deployment at night time or something, but we want to use that facility because we want to give developers a flexibility. Let's say if they can use that, right? Yeah. So what happens is we did this. Now help will check the state of the previous it was running. Now the deployment will happen with scale with the replica zero. So that I think this Angel Soldier doesn't have these functionalities. So with the helm upgrade, with some like labels and they can scale down or scale up with the replica zero. Because if they did that, now the developer wants to do, they can itself upgrade and now the application will be up because the last state was replica zero. Helm manages its own state rather than kubectl. It's not aware about kubectl state.
So I've observed this. So Helm does a three-way pass, right? So this stands true for even if you have done a, let's say, right, if you have scaled it down to zero and then if you do new deployment without changing the replica's value, it will not do the replica. It will not do a deployment. You'll have to change that particular replica's value in order to kick in a deployment, right? But let's say that if you're, so this will stand true for this scenario as well. But if you're doing a deployment from a tool like Argo CD, this scenario will not be replicated in that case. But this is a valid use case wherein Helm deployment fails. Even if you are scaling it, let's say you are using a scaler which scales down it to zero. In that case also it will fail. Any other questions?
So, like, I have one doubt. So, let's suppose if I'm developing one feature, and I integrate like Ada Core or Winter Soldier in it. So, let's suppose I have deployed that feature, and after testing there were some bugs. So, like, I have redeployed, like I made some changes in the code, and then again deployed it. So, in that case, it will automatically point to that pod, like you were talking that if I have deployed that feature in the environment, now QA can easily test that feature using the same don't need to deploy it again.
What is the question?
So like I wanted to ask is there any time saving in the deployment with these
No, it's not saving the time. It's saving the cost.
Cost.
That your infrastructure is incurring when it is idle. So it's saving that time of yours, and it can also aid in removal of garbage or cleanup of environment as well, because it also supports a delete operation. So let's say that you have these ephemeral environments set up, and within your organization, you may have this policy that you clear up all the resources on a weekend, right? So you can use this functionality, the delete operation of Winter Soldier, to do that. So we also have that implemented in our non-production environments, wherein we clear up all the resources because our testers and QA guys, they keep on deploying various Helm charts. So at the end of the week, we clear up all these resources from within the cluster just to stabilize it. So time saving is not coming up from this one.
or it will increase the time?
It will not exactly increase the time because it's scaling it down on a predefined duration, right? Your organization may have a different policy, and in that case, what you can do is you can do a quick
some quick hacks to override these. Like he said that in case of an application which is scaled down to 0, and redeployment will not kick in the new deployment, right? But you can always write a job and use pre-hooks to sort of scale, patch the applications to replica 1, right? And then this new deployment, whenever you are doing it, it will kick in. Keda is very beneficial for you if you want to do sensible auto scaling in Kubernetes. So there are times that CPU based or memory based auto scaling is not enough, right? That's when you use Keda to make more sense out of the logic that you are putting into auto scale your application. So let's say that I talked about consumer applications, right? So the consumer applications, they have a job, they process something in batch of 10, let's say. So I pick 10 messages from Kafka topic, I process it, I send it back wherever I want, S3, T3 or anywhere, right? So my CPU utilization is not going to increase in this case anytime. As much as I have, like if I have this batch size 10 fixed for this application, the CPU utilization and memory utilization is not going to increase, right? So in such scenarios, what makes sense is, let's say I have a huge lag in my Kafka topic, and I want to scale up to a higher number of consumers in that case, right? So I can scale on the basis of this lag that I have in Kafka topic. For this particular application, I can use the Kafka scaler of Keda. So in that case, whenever a lag is detected, it will kick in the scaler, and it will increase the number of consumer. That will increase your lag, and then it will automatically scale down these pods as well. So Keda supports a lot of scalers, including your HTTP request based, the one that I showed you, your maybe metrics from your CloudWatch, your Nginx, your Prometheus, whatever metrics you want to scale up, you can do it using Keda. Very, very powerful tool if you want to explore and make sense out of your auto scaling. Yes. Because a lot of organizations, they just put auto scaling on the basis of request, CPU and memory. And that may not make sense in most of the cases. So to make more sense out of the scaling and the metrics on which you want to scale, you should use Keda definitely.